Howdy, my name is Adrian Correa. I'm with Pulaski Technical College in North Little Rock, Arkansas. We're going to be going over Quality Control Inspector, and we're going to be talking about site monitoring and building assessment. This is when you actually go out and take a look at what's going on the job site where a job may be in process. So what I'd like you to take away from this session is some of the concepts of what an air barrier and a thermal barrier are. Okay. Sometimes you'll see the word boundary, sometimes you'll see the word barrier. When I talk about it, I usually will say barrier. However, all we're talking about is insulation. And then I need you to be able to recognize whether the appropriate energy saving measures were used or were installed. So that can come from a couple of places. That can come from something like the audit report, or it may come from the work order. You're going to have to take a look, and also that part of that is to look for missed opportunities. And that brings me right to the next item. Missed opportunities are when we ran an audit, however, we did not include everything that we may have wanted to do for some reason. Or there may have been some work, like a hole in the air barrier, that was not described in the scope of work. And we consider those missed opportunities, opportunities to save energy, opportunities to do work on the client's home that meet our goals, and yet they're not on the work order. So those would be considered missed opportunities. And then we need to consider whether the health and safety measures were justified. Are we installing CO alarms because there are no functioning CO alarms in the home? Or are we installing them because we install them in every home? If they're already there and they're already working and they're put into the manufacturer's specifications, they meet our standards for being used in the program, then why would we not just leave them alone? Why are we trying to replace them, in other words? And then you need to be able to judge whether installed measures meet the specifications that are established by your program. And in this particular case, excuse me, in this video we're going to be talking about the Weatherization Assistance Program and their standards. You might be working under another funding stream or in a for-profit situation, so you'll have different rules and regulations. You may be working with a utility, in which case they'll have a separate set of standards, not necessarily what the DOE is using for this particular program. The other thing that you need to be able to judge is workmanship. So what we want to see is being done when we go out and take a look, where they're applicable, we want to make sure that we run a blower door test, we do zonal diagnostic tests, we have run infrared if the conditions are correct. We want to do an infrared inspection. We want to run pressure pen test, and if our program is doing it, then we want to run duct pressurization tests. We want to meter the refrigerator. We want to take a look at domestic water heater temperature, see what it's set to, and make sure it's in a safe range. A refrigerant test, if applicable. Okay, that goes back to whether or not we're we need to make an adjustment to the AC system, the refrigerant in the air conditioning system. And then fan flow metering. These are the diagnostic tests that should be run coming in and should be run coming out. Okay. When we get to the job site, working in a consistent manner is probably the best thing to do. What I'm going to recommend is that you start at the front of the house and turn to the left. Okay. So start at the front door, make a left turn, and go around the building so that the building is on your right-hand side. And as you go around, what you're looking for are things that jump out at you. What does it look like as far as the structure goes? Do we have cantilevers? Do we have tuck under or attached garages? And of course, when you get there, you want to introduce yourself, explain what you're going to do, get their permission. If the weatherization crew is still there on the job, talk to them, introduce yourself, explain to them what they're going to do, get their permission to go around the job site. You really don't need it, but it's a good way to make friends. You don't want them upset at you because they're already going to be upset because they think you're you're the weatherization police there to bust them. So you're not. You're there to make sure that what they're doing is correct and to help them correct it, find the correct path if they're not on it. Okay. So again, you want to use the same pattern. You can either start at the top and go down, or you can start at the bottom and go up, but you want to follow the same pattern every time because it reduces wasted time and wasted efforts. You're not going over the same areas more than once if you don't need to. The other part of this is be sure and take lots and lots of photographs. Pardon me, just 1 second here. Oh, sorry about that. Okay, so you want to look in the inspection report for each measure that could have been considered for the home. You want to see that, first of all, the item was on the work order. If it's not on the work order, you want to know whether your site visit shows that it should have been. As a result of you going out there and taking a look, does it really need to be on the work order? And then if the measure is on the work order, figure out how good a job they've done with it. Is the quality acceptable? Is it unacceptable? Does it need to be reworked for some reason? Is it not correct at all? Did they do a beautiful job but on the wrong door? We're also looking to make sure that it meets our standards for quality and workmanship. And that again goes right back to, does it need to be reworked? Then the other part of that is if you accept it, then all you need to say is the work appears to have been performed to standards. If it is unacceptable, or you can't get to it, rather, then you need to say it appears to have been performed, but you can't access. Okay, you cannot verify. And then explain why you can't get in there. There's no access to the area because of, okay. And then if you see poor workmanship, the work is done, but it's not very good work, then you would say the work appears to have been performed to standards, but does not reflect good workmanship. Okay. If you've got some partial work done, some work was performed but not to standards. Okay. Work does not appear to have been performed but cannot verify. Again, no access to the area. So contrast that to the work does appear to have been performed. In other words, they've got empty insulation bags, they have empty tubes of caulk, they have screws and pieces of cut-off material, paint brushes with primer on them. So it does appear as though they did get into an attic, blow insulation. You can see some photographs of the insulation that they put in there, but they came back and put a repair in the air barrier, which is now wet, and you don't want to have them pull that off and cause a rework. But it appears as though they've done it, but there's no access there. They've sealed the access back off. However, if it doesn't appear that they ever cut an access to get into that part of the attic, and they've got insulation that's unused and they've got material that's unused, then that does not appear to have been performed. But again, you can't get in there to verify. All right. And then lastly, you've got an item was on the work order but not installed. So we may have something on a work order that they haven't gotten to yet. All right. Or if they're done, or they tell you they're done, doesn't appear like it was done. Now, for the purposes of this, we're going to talk about the thermal boundary. In some cases, you're going to hear a thermal boundary as being a combination between an air barrier and a thermal barrier. In other words, the insulation in the sheetrock, or the insulation and some other component that makes up an air barrier. Okay. In this case, we're strictly talking about the insulation. Okay. So this is the area that limits the heat flow between the inside of the house and the outside of the house. It's really easy to identify where it is or where it should be just by the presence of insulation. If you find insulation there, well, that's where they meant to put it. The location of where you find the insulation in relation to the room that it's trying to insulate and other parts of the structure really make a big difference in how well it performs. So, for instance, if it is not put out over the top plates on an exterior wall, then that exterior wall is going to be losing a lot of heat going up through the top plates, especially in colder climates when you have a higher delta T. Even small areas of missing insulation are really important. I want you to stop and think about an attic area where we go in and we put in R40 of insulation. We blow in R40, and then we come back and we remove 7%, an area of floor space that's equal to 7% of the floor area that we just covered to R40. What's happening is the design for this whole thing when we put the insulation in was to have an attic system that would work to an R40 value. However, because we removed 7% of it, 7% of the insulation is gone now in one particular area, 7% of the floor space has no insulation on it. Now the whole attic system is going to perform as though there's only R20 in that attic. So when you have small missing voids, they don't seem like they're very much, but they really affect the entire system. And this goes back to house as a system. They really affect the way the attic performs. It's going to bring it down by about 50%. So that's not a good thing. So the thermal boundary is usually pretty obvious. Here we see an attic full of cellulose insulation. We know that, hey, okay, there's no air barrier in the wrong spot. The air barrier is the sheetrock that makes up the ceiling of the rooms below, and we have insulation piled right up on top of it. So that's where they intended the thermal boundary to be, okay? If we don't know whether or not we've got a good air barrier or not, then what we would do is to start running zonal pressure diagnostics. We would look to see whether that air barrier is in good shape or not. Okay, we'll talk a little bit more about that. Now, here we have a case of they just don't understand the program. Okay, the workers that were working on this completely misidentified where the location of the thermal boundary was. They're trying to install an air barrier, and what they have done is wrap the attic gable with Reflectex, which is trying to act like, well, they're using it as an air barrier. Okay, the ceiling below is adjacent to the living, or the ceiling floor adjacent to the living space is the thermal boundary. In other words, the attic floor is the attic space, is the thermal boundary. That's where your insulation is going. Therefore, any repairs to the air barrier need to be below that insulation, not on that back wall back there, or the gable wall. That's really not good. Okay, when we bring our thermal boundary and our air barrier together, when we bring our insulation together with the air barrier, we need those to be in contact with each other. If you're going to get the highest performance that you can out of this stuff, and you want your insulation to perform to the level that it's stated on the packaging, you need to have an air barrier in constant, continuous contact with it. It can't touch in places and not in others. It needs to be in constant, full contact with each other. If it is not, then you're going to get heat transfer by convection into the insulation. Convection is movement of a fluid or a liquid. In this case, we're talking about the movement of air through that insulation, and it's going to start moving that heat. Instead of having 3.5 inches of insulation or 9 inches of insulation, you're going to have air moving through it, and that warm air, if this is your air barrier side over here, if you have a void, you're going to have convection in here, and that convection is going to get stronger and stronger as it heats up and move into the insulation. So your insulation may have started off at 3.5 inches, but effectively it may only be performing at 2 inches after a couple of hours, which means that you've lost a good bit of R value just from convective heat loss. Okay, now your air barrier is pretty simple. It limits the flow between the inside and the outside, but it's a lot more difficult to identify as far as where it is and what condition it's in, because it's not always where you think it is. We usually run the blower door to determine where the air barrier is and the quality of the air barrier. That's the air infiltration test. If we have a good blower door number, which is very low for a particular dwelling, then we say, hey, we've got a pretty good air barrier here. We don't need a lot of air sealing. Now, here's a question for you. What is in most of your homes, especially those built in the, let's say in the middle of the country and down, so Midwest and South, what do you think makes up the air barrier in most homes? Stop and think about that for just a minute. Okay. It's going to be drywall or the gypsum board. sheetrock, if you will. That's what makes up the air barrier in most homes. If you have plaster and lath, then of course the plaster is going to be the air barrier. Okay. All right, so when we have gaps in our thermal boundary, this is just a review, quick review of building science, so that when we start looking at these pictures, we understand what we're looking at and why we're seeing problems. Okay, so here, if we have gaps in our thermal barrier, such as right here, we have an air barrier, but we don't have an effective thermal barrier, then we're going to have heat rising through that area, and we're going to have heat loss. Okay, so there's heat rising, and of course it's going to transfer through the whatever the material the attic hatch is made out of, and then it's going to radiate and convect out into the attic. We don't have something there to stop radiation and convection, which would be the insulation. Okay, so when you get up into the attic, what you want to look for are what are the components of the thermal boundary? Do we have sheetrock and top plates that are making up a good continuous thermal boundary? What are the physical features of the attic? Is it open floored? Is it meaning that we have exposed joists everywhere, or is it floored? Is it a floored space? Is it cathedral ceiling? Is it a partial cathedral ceiling with a flat top? Do we have insulation at every different level? And is that insulation relatively the same? Did they find the bypasses up there, and did they seal them? Okay. If you have duct systems, like we do here in Arkansas quite a bit, if you have HVAC ducts that are running through the attic, are they insulated properly? A lot of codes require a higher level of insulation for ductwork that is in the attic than it does for ductwork that is in the crawl space or another area. Okay. So how about evidence of condensation or other moisture problems on the roof or on the sheetrock below? That would indicate that we've got a good, strong bypass that's working and putting a lot of moist air, or perhaps an attic fan, not an attic fan, but an exhaust fan for a bathroom or a kitchen or something like that, that's not properly ducted. We also want to look at the ventilation in the attic. Is it properly ventilated? Do we have enough split high and low to meet code? Did we install attic ventilation? If so, then for sure we've got to have it brought up to code. Do we have mechanical and plumbing terminations? In other words, a plumbing system uses vent pipes. You can think of those as soda straws if you want, that let air into the plumbing. And just as you can put your thumb on the end of a soda straw, or your finger on the end of a straw that's in a drink, lift it up and your straw will have liquid in it. When you remove your finger, that liquid's going to roll out or run out. What you have done is you've vented that drain. You know, think of that as a drain pipe. That straw is a drain pipe, and the top part of it is a vent. Sewer gas will exchange with the air that's around the opening of that vent pipe. So that needs to be outside the house. We can have methane and other really ugly gases build up in the attic. The other thing is we don't want to cover those with insulation. If we block them, then the drain pipes will not work properly. So those need to be terminated up through the ceiling, or I'm sorry, up through the attic roof. Okay. How about knob and tube wiring or other electrical hazards like uncovered J-boxes or splices that are not in J-boxes that are covered? So junction boxes are required by the NEC, and they also have to be flagged if we're going to cover them. They must remain accessible. By flagging, we make them accessible by identifying their location. Okay. Do we have heat sources that are properly dammed? Did we put insulation dams around all the type B vent and all the masonry chimneys, all of the, what am I trying to say here? Bathroom ventilation fans that may have heaters, strip heaters built into them. Anything that produces heat up there, have we kept our insulation back away from it? And do we have chutes? So chutes and dams. Are we putting chutes into the eaves where we have attic venting to prevent those areas from being covered by insulation, or to prevent the insulation from getting so close to the roof deck? So here's the roof deck. We don't want the insulation to come up so high that it cuts off the air path underneath that roof deck. So we'd put a chute in there, and then we may put a dam at the end of the top plate to prevent insulation from moving into that eave area back in the very corner there and blocking the air path for our ventilation system on the attic. So when we get up here, what do we want to look at? We want to look at this type B vent. Okay, we've got two runs of it, this one and this one. Are they correct? Are they properly supported? These don't appear to be properly supported. If we're going to bring insulation above the level of them, then they have to be dammed all the way around them. You can't encapsulate these things in insulation. Do they have damming around the base of them? Okay. Is the bypass that's created, do we have air path this way, in and out of the house or in and out of a wall in the house? If we do, that should be blocked off. How about plumbing vents? Here we have a big plumbing vent coming up. How about damming around the attic hatch? Okay, here we have an attic access. If we start blowing insulation in here, we're going to have it pile on top of the attic hatch or fall through. We have a gable vent over here. We're probably not going to blow insulation all the way up to the bottom of it, so that's one part of our venting system, or it may be just one half. The other half may be on the gable vent behind us that we can't see. We have a floored attic here. So what does that mean? We don't want to just loose fill underneath that floored attic, because what's going to happen is, especially with cellulose, you're going to get settling of that cellulose, and then you're going to have gaps in your insulation. So underneath the floor, we may blow 3.5 or 5.5 inches of insulation, but if we don't dense pack it, then we're not going to prevent settling of that. And in a year or so, at the most, that's going to settle down, and we're going to have a gap in our insulation there, which means that we can have convection working, and we're not getting full value out of that insulation. So we either need to remove the floor or dense pack under it. We need to do something with it. And then our joist bay cavities. What about each of these? Are they prepared and ready to have insulation put in them? Is there trash under there that we're about to cover up? We don't want to leave trash. Speaking of which, look at all the sheetrock back over here, or what appears to be loose boards and sheetrock. We've got a gas line running over here. Okay, we may want to flag the connection points on that gas line, because gas lines are not forever. Plumbers do work on them. They do need to find them. Okay, so here we've got a chimney. What about our chimney? Do we need to do something about damming around that? We've discussed the B vent and the pull-down staircase, the gable vent, our ceiling joist cavities, and our floored attic area. So when we look at air sealing, when we're specifically talking about air sealing, was it performed? Here we see a couple of areas where we don't have air sealing that was performed. And when they get large, like the one on the right, that's not good at all. So you can pretty much find these deficiencies just by pulling back a little bit of insulation. Be careful. Wear gloves when you do this, because you don't know what you're going to find down there. You may find sharp screws or other things that will cut you easily. So wear some heavy gloves when you're pulling this insulation back. You don't know what you're going to find underneath it. You want to trace wiring and find where it goes through top plates. You want to find where it joins junction boxes in the middle of rooms. And also take a look at your plumbing. Trace your plumbing penetrations back. And for everything that you see that is supposed to be installed, note the inspection report whether that measure has good workmanship or not, whether it is done properly to standards, whether you can get to it. Okay, all of this goes into addressing whether or not things that are being performed well. Okay, I want you to take a look. We're going to go through some things here. And what I'd like you to do is think about what you would put for each one of these photos that I'm about to show you. Think back to the previous slide where we were talking about the measure was performed to standards, or the measure was performed but has poor workmanship, or it appears the measure was done but I can't verify, but there's no access, or it appears that the measure was not done. I can't get access. Okay, those things. Think about what you would put. How would you judge this? Okay. So here on the left, what we see is properly sealed partition of the wall prior to installation. Okay, but on the right, we're seeing the entire length of the marriage wall in a mobile home that was left unsealed. Okay, this is the top of a marriage wall. For those of you who are not sure what a marriage wall is, in a double or a triple wide mobile home, the mobile home is brought out in two pieces, and where the pieces are put together, there's a wall section on one and a wall section on the other. They are brought together. Okay, usually the tops and bottoms of those are open and they need to be sealed. There is a method that the manufacturer provides to seal those, but a lot of times it's a real pain in the butt. The other thing is that they need to be properly aligned and leveled off so that everything comes together. You don't want them coming together at an angle or coming together slightly tilted. They have to be real level and plumb with each other when they're brought together, or they won't completely come together. That in of itself is not a horrible thing, but the big leak through that, the heat loss or heat gain through that marriage wall, that's a problem. So here on the left, we see that what appears to be work that was performed. Let's assume that it was on the work order. So how are we going to judge this? Are we going to say, all right, this is inferior work, this is superior work, this is really good, I don't care? No. We're going to look and say it appears to have been done to standards. Okay, that's it. It's on the work order, appears to be done to standards. On the right-hand side, however, it appears not to have been done. All right, this work does not appear to have been done at all. So that would need to be changed. How about here on the left? We have a heat-producing chimney. It's sealed with high-temperature caulk, but what is it sealed with? Okay, what is it sealed against? We've got 2x4 framing right up against a masonry chimney. How are you going to look at this? How are you going to judge this? This is a good situation to stop and think about, oh, what do I need to do? What really needs to happen? Well, one of the first things you need to know is whether that chimney is still being used or not. If this chimney is still in use or has the potential to be put back into use, if it's not one that has been taken out of service completely, but just the bricks haven't been removed, then what you're seeing here is probably acceptable. And you would say that work has been done, and note that the chimney is no longer in service and it's not serviceable. It won't be used again. However, if you think it can be, then this is probably deficient work. This appears to, work appears to have been done, but it's not to standards. All right, the improper material has been used here. We don't use wood. We don't want any combustible products within 2 inches of a masonry chimney. I'd recommend going out to 3, but a minimum of 2 inches against a masonry chimney. So this is not correct. It appears that they've used the proper caulk. That looks like high temperature silicone. I would want to check the label of the products that they have, or the invoices to see, or their material list to see if they even brought high temp caulk out with them. But it appears that it is the right stuff. However, it's sealing to the wrong type of material. Okay, that framing member probably should have been moved. Here on the right hand side, we have a 1 or 2 part foam that's used to seal, seal the top plate. Is this good or is this bad? This doesn't appear to be too bad to me. We do have foam used on the top plate that's acceptable. They appear to have done a pretty good job. It looks like whoever did it, however, probably is not the most skilled person. So the workmanship is a little deficient, but it's still to standards. So I would probably say work was performed to standards for that portion of it. How about here? We've got a beautiful blanket of insulation, okay, to depth. So we have insulation that's installed. So it appears to, it appears to be installed and it appears to be installed properly. However, look all the way at the back of the picture. What do you see back here? It looks like we have a masonry chimney back here, and we've got insulation that appears to be right up against it. So we can look at the bag counts and determine whether or not we have the proper amount of insulation installed per the work order. Okay, so let's assume that 1 bag of cellulose will cover about 18.3 square feet of attic floor to get to R40. 1,000 square feet would need about 55 bags, okay, to get R40 throughout it. So that's assuming there's no existing insulation in there. So that's one way that we can tell whether or not we've gotten to the R40 in that attic. Okay, depth is not your only indicator. In other words, how deep this insulation is not as important as knowing your bag count and a good measurement of the attic floor. Because the manufacturer gives us a specification of how many square feet maximum that we can cover of an attic floor with a bag before we're starting to fluff it in there and put it in at mixing too much air with it, and we're going to get heavier settling than we want, which means we're not going to wind up with R40, we're going to wind up with something else. So don't use depth just as your only guide. So here on the left, we've got a good example of work that was performed, but we've got some uneven coverage. If I start following the lines on this, you can see we've got hills and valleys and everything else running all over this insulation. So it's been done, but the workmanship's not acceptable. And then over here on the right, if we are looking for about 10.5 inches of blown-in insulation to get us to about R38, well, that should be up here. So we're about 3.5 inches shy of what should be done. So both of them are going to wind up being reworks. Okay. Here, we were talking about this earlier. If you have a floored attic, you need to check the density underneath it. So our flooring is this area over here. This is our decking. Okay, and we're coming in under this this way. That is oops. Let's erase here. Under is that way. That's going under the floor. And you can see we don't have very much density under there at all around this guy's fingers. We're not seeing the proper density under that floor. So that's probably an area that's going to have to be addressed. And what we're looking for is if you can move your hand through the material very easily, then air can get through it. Okay, it should be so dense that it's difficult to poke your fingers through it, and it should poke back. When you poke it, it should poke right back. Now here we have a beautiful roof, a beautiful job. However, how are we paying for this? If this is under the WAP, how are we paying for this? All right. Let's talk about this. This is an insulated EPDM roof. It's a rubber roof. It was not modeled in the building audit, and therefore it's not cost justified. It's nearly $3,000, and it's got sheets of 2-inch R12 extruded polystyrene insulation, which accounted only for 15% of the cost. Okay. In addition, the rubber roof membrane is black, and it has no reflective value. So if this is in the south, we just turned this thing into an easy bake oven, didn't we? So we need to look at this and determine whether or not a DOE approved priority list or approved audit confirms that this is installed or may be installed under the Weatherization Assistance Program. And again, you're going to go back to the Appendix A in your state plan to determine what is and what is not allowable. Okay. Coming out of the attic, how about an insulation certificate? Do we have one that is completed and posted? And I would also recommend that you talk to your crews about getting into the habit of stapling up a bag that they have used to fill the attic. The reason for this is if anybody ever comes back, DOE or anybody else comes back and says, well, no, maybe they used 20-pound bags, maybe they used 35-pound bags, maybe there were 17.5-pound bags. If there is a bag stapled up there that they installed, then, hey, it's pretty hard to argue with what was put in there, even though we've got this certificate that should be certifying that what was put in there, and this is the bag count, and this is the R value per bag. One step further to protect themselves is to put an actual used bag, empty bag, just wad it up and staple it up there. Okay. Do we have J-box markers and depth markers? So here we have a depth marker. Looks like it is about 9.5, 10 inches, maybe 9 3/4 right in there. And here we've got an insulation flag. If you're not going to use these real tall insulation flags, have them, put them on the rafters. That's another good spot for them. Okay, we need a depth marker probably every 300 square feet of attic floor. So you want to see a depth marker every 15 feet, roughly, is what we're talking about there. So 15 feet in any direction to a depth marker. Okay, so right here on the left, what we're looking at is a proper damming around a chimney. However, right in here, it looks like we've got some blown cellulose. So that would have to be cleaned out. That's something that I would talk to the crew chief about, just have them clean that out, okay? I'm not going to make a fuss about it, but it needs to be cleared out of there. And then on the right-hand side, we have a lack of a code-approved dam. Now, one thing that I want to bring into this conversation is the dam is required because of NFPA 200. That's the National Fire Protection Association, their standard 200, which deals with solid or wood-fueled appliances, and that's what we think that this chimney is going to be falling under, a wood-fueled appliance. They're saying that you need 2 inches to combustibles. All right. My question for whoever put these slides together, or is fussing about the code-approved dam, and these photos are courtesy of the Department of Energy, all right, is what is the material of this insulation? If this is fiberglass, then we need to look at the manufacturer of the fiberglass and see what they say their fire rating on that is. I think you're going to find that blown-in fiberglass insulation does not burn. Okay, it doesn't need, in other words, it's not a flammable, it's not a combustible, it doesn't need to have that clearance. So then my question becomes, do we need a dam there or not? And if one is there, are we just putting a hole in the thermal barrier? Something to think about. Okay, talk to your program and see if they have, if they have a definitive answer for you there. That's one place where you might have a conversation with your monitor. They may see that this type of thing on the right and want to see it looking like what's on the left. All right, you may have to explain why it does not and what the justification for that is. They still may ask you to put a dam in there. Okay. All right, here on the left we have a weather stripped, insulated, and secured attic hatch. Now we're assuming the insulation is there, but they're telling us there. On the right, it's uninsulated, it's not weather stripped, there's no insulation dam. Okay, so these are things that we need to look at and consider as we judge whether or not we have good work here. The other thing is this attic hatch on the left looks new, so if it's a modification or new, it's going to have to comply with building codes, which means we've got to have the headroom above it and a minimum size. But I do like the use of the window sash locks here to put pressure on that weather stripping and to compress it, to push it down so that it does a good job. Okay. Alrighty, pull-down staircase cover. Here we've got a good one. It appears to be weather stripped back here. It's sealed with a commercially available fabricated lid or with something that is site built. Sometimes you can just take and build up levels of foam that's 1 inch foam. It should be the same R value as the rest of the attic. When our standards call for any attic access or scuttle hole should be insulated to the surrounding structures, which in this case would be the attic. So if we have R38 in the attic, we need an R38 attic hatch. Alrighty. Insulate hatches, not insulate your hatches. When you have a scuttle hole cover, what we're looking for is insulation, preferably a solid insulation, not a fiberglass bat, because what's going to happen with a fiberglass bat is that as this cover gets removed and set aside, the bat's going to get destroyed. We need to have a dam around it, a proper insulation dam. Okay, we should have a good weather stripping or some kind of gasket that allows the hatch to pull or to put weight on and compress against that gasket. One thing that I do not see on this that I would like to see is some kind of mechanical cover or a mechanical fastener to be sure that that weather stripping has pressure on it, especially if you're using something like the vinyl bulb type, which is used weather stripping used around the doors. It usually comes on a metal on a piece of aluminum about that wide with holes in it, and then there's a track in the side of the aluminum that this vinyl is slid into. That can be pretty stiff, all right, and it may not be perfectly level across the top of it. If you push it up against the hatch, it may actually just raise the hatch. The hatch may not have enough weight to really compress that. So having a little mechanical fastener, something that will force that hatch down against it, is a good thing. Now in the case of a pull-down attic stair, the difference here is that the cover is going to go up and out of the way. Here, this is going to go up and then out of the way this way. So the cover goes up, but our stairs are coming down. Now, yes, we do have some air that's going to move around in that area, but nothing's perfect. All right. Again, we want an insulation here that would preferably be rigid, not fall off. It's probably going to take some bangs and bumps. We still need a dam, and we still need weather stripping around this. Okay. All right, uncovered junction boxes. They're here. It's a little difficult to see, but we have wires in an open junction box. Those need to be covered. Here we have a disconnected vent fan. Okay, so we want to make sure that first of all that we flag all of this. As a matter of fact, look at all of the frost and moisture on that roof. We're seeing a lot of moisture damage, and it also it appears as though the insulation may be moisture damaged as well. Okay, we've got knob and tube wiring. According to the DOE or to the NEC, you cannot envelop knob and tube wiring in thermal insulation. Now, this is also going to depend on the authority having jurisdiction. Some jurisdictions allow it to be encapsulated as long as it has sufficient circuit protection. The knob and tube may be brought up to code as an energy-related repair. It depends on your state, the state plan, and whether or not your health and safety plan has had electrical or specifically knob and tube moved over to what am I trying to say? Into the incidental repair categories. If it is corrected as an incidental repair to insulation or to attic prep, then the entire measure, the attic prep or the insulation measure, has to have this incidental repair rolled into it, and all of it has to have an SIR of 1 or greater. So anytime you're dealing with an incidental repair, and we talked about this earlier, the incidental repair in and of itself does not get an SIR. Okay, it gains its SIR by whatever measure it's coupled with. So if we're going to correct knob and tube in order to insulate, then the insulation job has to include the price of the knob and tube correction, and all of that still has to have an SIR of 1 or greater. All right, sidewall insulation. When we're doing infrared scan, especially when we're using it with a blower door, what we're looking for is a uniform color without big variations in it. You will see some variations. Always know what's on the other side of your wall. If you're dealing with a solar loaded wall, you're probably not going to have a very good infrared scan. Okay. You always want to look at it from the cool side as well. Here, what we're looking for is light colors being warmer temperatures, and dark colors being colder temperatures on the surface. So if this is a cold day, if we're in a heating environment, colder temperatures are going to indicate that we're losing heat faster through those areas than the lighter temperatures. Here on the right-hand picture, we are seeing some insulation voids, or what appear to be insulation voids in that gable wall from a poorly done dense pack job or something like that. Also bear in mind that if you are looking at this during the summer, these colors are going to change. Instead of seeing dark streaking, you're going to see light streaking where heat is coming in. Now, in a walk-up attic staircase, in other words, a case that is built in, you've got to make a decision here. Are you going to push this staircase out of your thermal envelope, or are you going to pull it in? So that's something the auditor should have done already. And if you're going to push it out of your thermal envelope, that means that you're going to have to come in and put in insulation and air barrier corrections all the way around this thing, and the whole staircase is going to stay at the temperature of the attic. If you're going to pull it in, then that means that you're going to come in here and you're going to build some kind of air barrier and thermal cover to go over the top of this one big giant hatch. So knowing, come back here, knowing what the audit is calling for is the way that you're going to judge whether this was done correctly. And yes, they should be. They should be. They've got sidewalls on them, and they should be treated just like an exterior sidewall. We either want to dense pack those or put a bad insulation up with an air barrier on both sides. How about other sidewalls? Can you think of some other sidewalls that might need to be insulated somewhere else in the house? How about a sidewall between the garage and the kitchen? The garage is an unheated space, so if we have an attached garage, we probably want to do that. So there's probably a lot more of these types of walls than we realize. Now, this is just a representation of what I'm talking about from the earlier slide. If we're going to push this this staircase out of the heated space, we're going to have to put a thermal boundary and an air barrier all the way around it. If not, then we need to top it with a thermal boundary and an air barrier. So that's all this slide is representing, is where should those be, how should those be done, all right? Knee walls, especially down here in the south, those are probably our biggest heat loss areas. So here on the left, we have a knee wall that was insulated and covered. I have a slight issue with the way that they have done this. We have stapled this Kevlar here, or this Tyvek, in each spot. I think if they had gone across the top, we also have a lot of gapping at the top. The workmanship ain't great, but that's probably a really cramped space, and I don't know if I could have done better. But just looking at the picture, I've got a lot to say about it. Isn't that always the way it is? You know, you could have done a better job until you got there and didn't do a better job. So I'll leave it alone, guys. Good job. Y'all did it, I didn't. Good job. Here on the right, however, we've got insulation that doesn't have an air barrier on it. We have blown insulation on the floor and of this attic area here, and we have exposed bad insulation on the wall. We need to have some kind of air barrier. Most likely this is a ventilated attic. We have air that's trying to move this direction and over the top of those bats up a slant wall to the top attic, or to a vent system that would be higher up in the rafter system. But what's happening is we have cool air coming in low on this and then rising, and that air is going to start convecting as well. In other words, it's going to start a convective loop and driving heat right into that insulation. As it drives heat into that insulation, it is going to make the insulation act like it's not nearly as thick as it is. So if we have 3.5 inches of installed insulation before it's all said and done, that stuff may only be acting like there's 1 inch of insulation there. The other problem is that here is the end of the stud. Let me try and draw this a little bit better. Here's the end of the stud, and look how much we have exposed of that stud. So this is a case of poor workmanship as well. If we installed this, if our folks installed this, we need to have something done about that. Okay. Here's another look at that, and this is what we were talking about earlier. This is that attic, or the sidewall. I'm sorry, the knee wall that we were talking about. The goal here is to air seal at the top plate back over the exterior wall, at the floor that runs underneath of this bonus room right here. Okay, call it an upstairs bedroom, bonus room, story and a half, whatever you want. We also want to air seal the intersection where the sheetrock or there are other air barriers where they transition on that slant wall at the top and bottom. We don't want air moving up this wall and into this attic. We don't want it moving from under here or here up through the wall. Now, to move this way and back out is fine, because that's going to help keep the roof decking moisture free, or at least that's what the codes tell us. Okay, so if we're going to buy that, then that's what we need to do. The other thing is we need to make sure that that attic up there is been properly treated. These are areas inspectors don't like to get into because they're always tight, but we need to get into them and make sure that our crews are doing a really good job in there, especially here in the south, where knee walls tend to have the highest delta T in the house. We can see a 70-degree delta T across that wall, and that is a huge heat driver or motivator for heat to move. We don't want to lose a whole bunch of stuff, a bunch of heat through that. So when it comes to finish work, we need to look at the quality. Here we have plugs that have been painted, but and they're painted to match. The only issue that I have, and it's very difficult to tell from this photograph and without looking at the rest. So let's assume that the client is happy with this job and that the crew has done everything that they can do to blend those plugs back in. Okay. On the top right hand side, it appears though that we've got some siding that is not properly attached and that it has been stretched in order to reconnect. Okay, we may have disconnected it at one time of the day, left it for so very long that everything around it kind of shrank up. Now we're trying to get it to hook back into everything. The proper thing to do would probably to have been to release more fasteners and give us a little bit more room to pull everything back together. Okay, and down here at the bottom, the siding was not properly overlapped. It's very important, especially with vinyl and aluminum siding, that you have an overlap there, or you're going to have a large amount of water come in through that cladding. Okay. Let's see, what else? What other special features are you going to have on a home that you need to look at? Well, how about a cantilevered floor? This is very much like that attic floor. We can have air that will move through this floor system and up these walls, okay, this way and this way. And what that does is it causes radiant coupling for any occupants that's in that room. The air temperature may be at a good temperature. However, the difference in body temperature and surface temperature of that wall and somebody in there may be great enough that it's making them feel uncomfortable, either because they're picking up heat from that wall, the wall's radiating heat to them, or they're radiating heat to the wall and they're feeling cold and clammy and chilly in there, but the air temperature itself is good. And that may be because we are bringing in and cooling down the inside of that wall too much, and our insulation is not working. So there at that cantilevered floor, we need to treat it. Here on the picture on the right, we can see some very good examples of cantilevered areas. As a matter of fact, even on this bay window, we have a cantilevered area that needs to be dealt with. And then we've got these exterior walls over here that are around this inset door. In this, we would call this home here in Arkansas, we'd call this a split level. Okay, this is what our basements look like here in Arkansas, where they're half exposed in the front and they're walkout in the back. You can just walk right out of them in the back. Okay, let's take a break here. We're close to an hour. We're going to be probably another hour on this, so we'll stop this and call this part one, and we'll come back and get back into this. See you in a minute.